So hello everyone, we have a 7th contest discussion today. Results are pretty good actually. The contest was a little bit easier than the previous one, yes. So it's kind of expected, but still very good for you, solved a lot of problems. Let's discuss them. So what we have today. So problem 1 is about pangram. You just need to check if the given string is a pangram. Pangram is just the string which contains all the letters of your alphabet. So we're given a string and we need to check if the string contains all the characters of the alphabet. That's all. No, how you do it? No, just like this. You check if your string contains all that. So there are multiple ways to do it, I believe. So no, let's try to do it like this. So we have n. Let's do it just to make a set of characters. Maybe one of the problems is that you have capital letters and small letters, so you need to kind of put them to the same case. How to do it in C++? Actually, I'm not sure that good in C++, so you can see it to lower. To lower. Oh, you have here to lower S I like this. What problem? Does it take string or not? Okay, should work, I believe. Okay. Now you check if size equal to 26, then you solve this. Something like this. And no, and this is yes. Pretty straightforward problem, just to have something to start your contest. Judges usually put some simple problem as the first problem, just so you feel confident that you can solve something. And you can just to stretch your brains, you know, as the first problem. Good. So this problem A. Let's not wait. Let's go to problem B. Problem B looks like this. We need to calculate some strange sum. Some works like this. I take all numbers from 1 to n, some of them with plus, some of them with minus. And I take with minus only numbers which are powers of 2. So each power of 2 will go with minus. And all other numbers will go with plus. Again, multiple ways to solve this problem. What you can do. If you want to calculate, if you just calculate sum of all numbers, just 1 plus 2 plus 3 plus 4 plus and so on plus n, you will get simple sum of arithmetical progression. Sum of arithmetical progression is just n by n plus 1 divided by 2. Yeah. Now we need to do the same thing, but some elements go with minus 1, minus 2, minus 4, and so on. Yeah. So let's look at all these numbers and just subtract them from this sum. So to get from this sum to our required sum, we need to subtract it twice. So we need to subtract 1 twice, then subtract 2 twice, then subtract 4 twice, and so on. Yeah. So then we go from plus to minus. If we just subtract once, we just remove this element. Yes. If we subtract it twice, first we get 0, then we have minus 1. Yeah. Well, that's all. We will calculate this sum, then we'll calculate sum of all powers of 2, just using simple loop. It should be fine. So we have not that many powers of 2 in this sum. So n is up to 10 power 9. So we have like up to like 30 powers of 2. So we'll just calculate sum of these powers of 2 and subtract it from our resulting sum, and we get the result. Let's go. So let's do it like this. Let's multitest. Okay, so we have. I'll do it in longs. So we'll say the sum is n by n plus and plus 1 divided by 2. It's not Python. And now we need to subtract all these powers of 2. So I'll start with powers of 2. So we'll start with k equal to 1. And then while k is less or equal than n, yeah, I will subtract it from my sum and go to the next power of 2. That's all. Let's see, so calculate total sum and then subtract something. Again, it's very popular in this problem in computative programming when you need to calculate some strange sum, and what you need to do is actually to redistribute the element of this sum in such a way that it's easier to calculate this sum. Yeah? Like here, I've like kind of split all elements of this sum into two sets, like elements with plus, elements with minus. And I separately calculate these elements, calculate these elements, then combine this and get the total sum. So, looks okay. So let's submit it. Good. So second problem is, again, requires some thinking. Yeah, and compared to the first problem, when you just need to implement what's going on, it's just simple implementation problem. Here you actually need to think. If you just calculate normally this sum, you'll get time limit. So because n is up to 1 billion, you can calculate sum of billion elements in 1 second or how many seconds you have. So you need to some thinking how you calculate this sum fast enough. But still, again, it's not very difficult problem. Let's go to problem C. So in problem C, no, you actually have a long statement that explains you what's going on, and it's not that simple anymore. So so you have, first of all, have two constants, m and k. So m is number of clean balls and number of clean plates. So you have some balls and some plates. With the n days. Good. So you can cook two types of dishes. First type, you can eat from bowls and dishes only from bowls and plates. Okay. So you have two types of dishes. First type, you can eat only from the bowl because it's some liquid, I believe. And the second time, you can build from both bowls and plates. Good. Fill is dirty plate behind philosophy is could sometimes eat first before eating. Okay, so if you don't have any clean dish, then you go and clean one of the dishes. No, plate or no, not dishes. Okay. You clean one of these, how it's called, not plate or bowl, what's called, kitchenware. Okay. So every time, if you don't have any clean bowl or plate, you can wash one of the dirty ones and go. Minimum number of times Valerie will need to wash plate or bowl if optimally. Now, what does it mean play optimally or act optimally? What does it mean? It means you kind of want to minimize number of your washes. What choices you make when you you need to make following choices. First of all, when you cook a dish, so you're given the types of dishes you cook. Yeah. So dish of the first time you can eat only from the bowl, so you don't have any choice. Yes. So you need to take a bowl. If you don't have a clean bowl, you need to clean one. Yeah, very simple. No choice here. Now, when you have dish of the second type, you actually need to choose. Yes, so you can take a bowl or you can take a plate. And if you don't have anything clean, you need to choose which one to clean. It actually doesn't matter. So if you don't have anything to clean, you just you pick some item, clean it, and then immediately it's dirty. So there's no choice here. So the only choice we make is when we have dish of the second type, we need to choose what to use, bowl or a plate. Yeah. So that's the whole choice we make in this problem. And if you think about it a little bit, so the optimal choice is always to use a plate. So if you have plates, you can use them only for dishes of the second type. So if you have any plates, you can just use one of them. Yeah, because there is no, it can be used for dishes of the first type. It only can be used for dishes of the second type. So every time you have dish of a second type, you can use one of the clean plate if you have one. If you don't have any clean place, then you use ball. And again, this all is just written here. You just need to read it carefully and think. So again, what are the steps how you solve this problem? You see here that you need to minimize something when you act optimally, and you think again, but what choices do I make when I do it? Yeah, and you just carefully think what you can choose when you find the optimal solution. And it turns out that you only choose one thing here. When you have dictionary concept, you choose what you take, ball or plate. All other choices are predetermined, so you don't make any choices basically. Yeah, this is the only choice you make. And then you think, okay, how would I choose here what to take, ball or plate? And again, it's naturally it's again, if you don't have enough intuition, just train your intuition. Maybe that's the result. But it kind of looks obvious that you need to take plate if you have one. Again, because you only can use plate here. There's no need to save this plate for later. Yeah. So let's implement it like this. So what we have, N, M, and K. And we have array A. Let's just don't solve the array. I'll just read them and calculate. Okay, so I'll just read them one by one and immediately process. Yes, so I don't save them in the array. So if x equals 1, do something else. So if x equals 1, then I need to take some empty clean ball. If I have clean balls, ball is m. So if m greater than 0, yeah, then I take one empty ball and it's fine. If not, then I need to clean one ball and use it. Yeah, that's the only choice. So I'll just calculate number of times I clean something. Then nothing changed. I clean this ball, I use it, and it's dirty again. Yeah. Now, if I have dish of the second type, I have more choices. So if I have clean plate, if k is greater than 0, I just use this plate. If not, if I have clean ball, I use this ball. And if not, I need to clean something. Doesn't matter what you clean, you just increase number of cleans you need. Some boring examples. Let's take this one. Yeah, it looks fine. So algorithmically, this problem is kind of easy, but again, there's a long statement. You need to read it. You need to understand, and you actually need to apply some reasoning to what you actually want to do. Okay, Codeforce is slow today, but it will be judged eventually. So let's move to the next problem. So in problem D, we have n robots standing in line. It doesn't mean they're robots; they just let's keep robot. So we have n robots standing in line, and they kind of wanna know each other. So each of them repeats all the names starting from the first robot. So first robot tells his name, then second robot tells name of the first and second, then for the first, second, third, and so on. So if they have if they have names like the identifiers, so yes. So I think that's why they are robots, because normally you put your names here. Yeah, well, like when you wanna know all names in a group, yeah, so you just repeat these names. But here we have numbers, so again, the authors decided it would be better to have numbers as identifiers, not names. So we have first identifier, then first 2, then first 3, then first 4, and so on. Yeah. So we have this sequence of identifiers. We need to find element with index k in this sequence. That's all. So how we do it? Let's move it here. Okay. So what your sequence consists of? So you have first element, when you have first two elements. So let's let's find index of this. So element 1, then elements 1 and 2, then elements 1, 2, 3, elements 1, 2, 3, 4, elements 1, 2, 3, 4, 5, and so on. Yeah. So we have these blocks of elements. So to find element in position k, I will find the number of block, yes, and then my number inside this block. Yeah. So to find the element, to find this element, you need to find your position inside your block, and we just have a small number of blocks, so we can do it in a very simple way. So we just so we have just n blocks. Yeah. So I will just iterate through all blocks and check if my k belongs to this block. Yeah. To do this, I need to know the indices of this block. So I need to find index k. So for each block, I will find index of the first element, index of the last element. Actually, first element is enough. So first, and I know the size of the block. So I will know the index of the first element and the size of the block. Let's call it S. Yeah. So my block will contain all elements from L to L plus S minus 1. Now, if K belongs to this range, then I know it belongs to this block. So I just know its position, just subtract L, and I will get the position of K in this block. Pretty straightforward. So let's do it really quick. So we have M and K. I don't like these 2 points. Let's make K just to be sure. So when you see some number which is close to the upper limit of the 32-bit integer type, just make it long. Just not think about it. So because if it is 2 multiplied by 10, if you add something, you may get integer overflow. You don't want to have integer overflows. So just to be sure, I will put it into too long. Okay. Maybe I don't need it. Yes, but it will not hurt. Okay. So we just this and we identifiers. So these numbers are also up to billion, yes, but I will never sum of them. So I'll just keep them as identifiers, yes. I don't make any arithmetic operation with these numbers, so it's fine to keep them in integers. But for k, I will do something. So I will subtract something and so on. So just to be sure, it's okay. Let's see. So again, like we discussed, so we have L equals to 1. No, we'll calculate from 1 or from 0. Okay, let's do it like grown-ups. So let's count everything from 0, and I will subtract. So now all the numbers are from 0. Yes, we use 0 indexation everywhere when possible. Yeah. So index of the first element will be L, and the size will be 1. Now I'll just check. Well, why I say why true? Because I don't know 1 to 8. So I will just do well truths. It's just easier. Then if I don't know what to do, I'll just break. Now I check if my k belongs to this. Again, my range is from L to L plus S minus 1. Yeah. So I check if my k is greater than L. It's actually, you don't need to check this. It will always be greater, but just okay. And k is less than L plus S. Then you output the result. So result in my case is my index in my block. My index in my block is k minus L. Yes, and it will be 0 index. So when I output it, I make plus 1. Yeah. And then if it didn't happen, I move to the next block. I move to the next block by making L equal L plus S. Yes, move to the next block. L plus S is the index of the end of my block. Very easy. And plus plus. That's it. You need to output, okay, you need to output, not this, you output the index in the array, okay. And you don't need +1. Oh, come on. Is there a contest right now? No. Why is it so slow? Something being rejudged right now. Conference problem. So let's look at your solutions. Okay, problem D. Okay, runtime error. Oh, sorry. You don't see this because I'm a manager of the contest. I see. Yes, I see this information. So yes, yes, you just have the problem here. Again, integer overflow is one of the most common problem in competitive programming. So you just need to be careful about not overflowing. Basically, every time you see multiplication sign, you think, okay, what am I multiplying? Is it possible that I multiply these things and it goes above the maximum limit of the integer type? If it probably will, just use long. And not some people actually use long for everywhere, so just make define int long. It's also possible, but I usually don't do it. So I'm just trying to be careful not to multiply two integers in 32-bit type. So again, every time you multiply something, you think, okay, am I multiplying small values or big values? If these values are up to 10 power 5, then you multiply and get integer of 10 power 10. 10 power 10 will not fit into 32-bit. Problem E is actually easy problem, but it is geometry problem. Okay, so when you have geometry problem, it always increases the difficulty of the problem because people just don't like geometry. Actually, if you learn how to solve geometry problems easy, you will have a big advantage in the programming competitions just because many other people do not learn it. Yeah. So what's happening in this problem? So it has, again, long statement, but the problem itself is really simple. So you have a circle, yeah, and you want to move it from one position to another position. And you move the circle just by fixing the point on a border, and then, okay, you have picture here. So we fix the point on the border of the circle, and then rotate the circle to some other position. Okay, and we need to find the minimal number of operations to move the circle from one position to another. Okay, so first of all, let's understand what this operation actually means. So what will happen if I fix one of the points and move my circle here? Where can I end? What can be the final position if I do this operation? And immediately you see that you can go very far from your initial circle. Yes, your center of the circle will move to maximum like 2r from the initial position. So maximal distance you can travel is 2 radiuses of your circle, like one diameter of the circle. What we call radiuses, so 2 radiuses of your circle. What other restrictions? Can I move to any position which has distance at most 2r from my initial position? And if you think about, yes, you can move to any position. So if you start from here, you can move the center of your circle to any position in the circle of radius 2r from it. Yeah. So no, just because if you look at any other position, you find, again, you build these two circles, find the intersection point, move your pin into this. Well, no, you probably have 2 intersection points. Okay, let me draw. So if you have some initial circle and you want to move it here, let's say, what you can say, you can put pin in this position and just rotate your center from here to here. Yeah. So it's possible to put the center to any position such that this distance is at most 2r. And now problem looks much easier, yes? So you have the initial position of your center, and you need to move it to another position. So again, so you have some initial position, you have some final position. You can make jumps of size at most 2r, or 2r. And you need to find the minimal number of jumps. No, it's easy that your number of jumps is just total length, this total length, let's say L. L like this. Divided by 2r. Yes? Seal of this value. So this is basically your result. I actually don't know if we can do it in doubles or not in this problem. 10 power 5. Do we have enough precision in doubles? Let's check. I'm not sure. I will show you how to do it in integers as well, but let's just try to do it in doubles for simplicity. So let's say r x1 y1 x2 y2. Let's call them doubles. So I'll call distance then. Okay, let's call distance. Do you have hypotenuse? Oh, you have hypotenuse. X2 minus x1, y2 minus y1. Doesn't matter, but okay, just for the beautiful code. Yeah. Hypotenuse just calculates the size of the hypotenuse of this side. Okay. And now to check sale of d divided by 2r. Will it work like this? What do you think? What's your prediction? This code does exactly what we are supposed to do. I actually have no idea. So let's try. So we actually can solve this problem using just doubles. So we have enough precision to calculate all these numbers correctly. If you want to solve the same problem in integers, what you can do? So first of all, we can calculate this length because this length is not integer. So what I will do instead, I will calculate it square of this length. It will be d square, and the square of is just x minus 1, 2 again by Pythagorean theorem. We have something like this plus. You need to put this to function. I'm just lazy. Okay. So this is the square of the distance. Now here I need to calculate distance divided by 2r. Yeah. So what I will do instead, let's calculate square of this number. Square of this number will be, so square of the result will be d square divided by 2r square. Yes, by 2r square. So it's like 4rr. Okay, r2. It's the result, not radius square, but result square. Yeah. So this is the square of the result. Yes, and I want to round it up to the closest integer. Yeah. So how you calculate division when you round up to the closest integer? You just make d2 plus this thing minus 1. And now I just need to find the square root of this number. So I need to calculate the closest number which has this square root. No, we talked about it last at some point, I believe. So how we calculate it? So it's square root of res2. Yes. And I need to round it up. So while res my res is less than res2, I will res plus plus. Something like this. So again, the trick is to use integers while you can use integers. Okay, okay, bad idea. It was bad idea. I'll just check it from here. Again, it's the same solution, but without you using any double. No, so here I used actually double. So this square root produces double, but then I kind of I fix it here. Okay, but all these intermediate calculations are all in integers. Okay, that's how you calculate stuff like this in integers. Good, let's go. So what we have in problem F? We have picture like this, very nice picture. So we have some table 3 by 3, and some of the values are already fixed, let's say A, B, C, and D, and some values are not defined yet. So you need to put some values instead of these question marks in such a way that these thing satisfies and this thing. So if you look at this, you need to care about this part. So if you look at any square 2 by 2, the sum of elements in the square should be the same. So any square 2 by 2 should have the same sum. Question, what's question? Question is to how many ways actually to fill these question marks with numbers in such a way that you have the same sum in any square 2 by 2. Do I have any restrictions? Which numbers to put? N is okay. I can put integers up to n. Where is right here? So I can put integers from 1 to n. And I need to count how many possible squares I can get. So how many ways to put integers from 1 to n instead of these question marks in such a way that the resulting square is good. So every square 2 by 2 is has the same sum. Let's see. So what we have? You have this table 2 by 2 for 3 by 3. Let's try to fill it with some number. So imagine you put some number x here, and then some number y here. So now you know the sum you need to get. Your sum is actually a plus b plus x plus y, because sum of this square, of the top left square. Now, when you know the sum you need to get, you know all other integers. So this integer should be s minus a minus c and minus y. Okay? So if you put this s here, this value, if you put it here instead of s, so you eliminate a, you eliminate y, yeah. So you have b, yes, plus x minus c. That's it, yeah. So value is this in this cell must be b plus x minus c. And then in the same way you can fill all other 3 corners. So in this corner you will have again this sum minus d. So it will be it will be a plus x minus d. Yeah. It's easy to see which elements will be eliminated. So you have this square and this square. Yeah. So this b and y belong to both squares. So if you calculate this sum minus this sum, you eliminate b and y, you have xa minus d. Yeah? And here you have, well, here it will be a long one. So you have x plus a plus b minus c minus d. Yeah? Now, immediately, what you need to know, what you can notice, that all these sums only, all these elements only depend on this number x. Yeah? So you don't have any number y in this place. So again, how you build this square? What do you think? Okay, I need to build the square, so all the sums are the same. So let's fill one of these squares, and then we can deduce all other numbers in this table. So I put this x, put this y, and then I can calculate all other numbers in this table. So you can put number b minus x minus c, this number here, this number here. Then you look where is x, where is y. So you have x here, yeah, and you have y here. Now, immediately you see that y doesn't make any difference. So you can put any value y here and it will be fine. And it actually makes sense because this central number belongs to all four squares. So if you change this central number to anyone, to any other number, you will have again the same situation. Yeah? Again, if you increase this central number by 1, you increase all the sums by 1. So all the sums stay the same. So this central number may be any number. Yeah. So again, the result like this. You can put any number in the middle. Good. So there are n ways to put it. Now, what you can do? You only care about number x. So which number x you can put? No, you can check. You can check all numbers from 1 to n. And then you need to check that these three numbers are good. So each of them belongs to range, so it needs to b plus x minus c belongs to range from 1 to n. And all other sums, a plus x minus d and x plus a plus b minus c minus d. Again, this problem n is pretty small, n up to 10. So you can just check all the values of x. So you can check all possible x's, check if this is correct or not. It's actually possible to do it even faster. So if you look at this, for example, this. So what it tells you? It tells you that x. So if you move, let's rewrite it like this. Let's rewrite it like this. So I need to have b plus x minus c, at least 1 and at most n. Yeah. So let's move this x. Let's keep this x here, but b minus c move to this side. So I will have x greater or equal than c minus b plus 1, yeah, and less or equal than n plus c minus b. Yeah. Now I just added c minus b to all parts of this equation. So it means that x belongs to some segment. Yeah. So every quarter of this square basically tells you that x belongs to some segment. Now, to calculate all possible values of x, you just need to intersect all these segments. So it's just segment intersection problem. Let me show you both solutions actually. If we have, do we have time? Oh, okay. Let's say we have time. Not that hard problems today. So let's say we have time. What we have? N, A, B, C, D. Okay. N, A, B, C, D. So again, y is any number. Yes. So. So I'll just calculate for x equals 1x and x plus plus. Because I will multiply it. Yes. So in the end I will multiply res by n, because I need to pick value y. I have n possible values y. So I'll just do it like this. That's the plan. Yeah. Now here I calculate all possible values of x. I check if, well, just look at this picture. If b plus x minus c is at least 1 and b plus x minus c is at most n, and I'll just do it like this. A plus x minus d is a, don't do it like this. You will just make mistakes if you're not careful enough. X plus a plus b minus c minus d is at least 1. Just move it to function, okay? I'm teaching you bad habit actually. Don't do it like this. S plus plus. Okay, while we wait, let's discuss other approaches. Okay, so I'll just keep this approach. We will just submit it, but while we wait, while Codeforce it's not working, we will let's try to do the same problem but using this segment approach. So what is the idea? The idea is to look at this segment and intersect them. Yeah. So I'll do it like this. So there are a couple of segments. Yeah. Let's do it like this. So I will say vector of where I'll put longs just because I can. So I'll just put segments in this array. Yeah. So first segment will be from 1 to n. Let's use a place flip. Okay, C-line. You're very smart. Okay. So first segment is from 1 to n. So I want to put all constraints on number x. First constraint is number x should be from 1 to n. Yeah, I'll make it inclusive because I can. Yeah? No one cares. Now, I will add all these constraints also. So I'll seg and place back. So this constraint is from c minus b plus 1 to n plus c minus b. Okay, let's just put it plus n here for. Now, I add the same constraint for this. So this cell will produce the same set of same segments. So it will be just not C minus B, it will be symmetrical, will be D minus A. Yes. And finally, the last one, so this one. Yeah. So again, I need to subtract something which will compensate this part. So it will be D plus C minus A minus B, and here D plus C minus A minus B. Again, don't copy paste this code, just use normal code. Now, in the end, you want to intersect this segment. So how you intersect segments? You calculate maximum of the left borders and minimum from the right borders, and it will be your intersection. So I'll just say, okay, left will be, okay, how you calculate maximum? Like this, let's say. Why not? Like this. Yeah, not the best way to do it, but good enough. So you calculate minimum of all right borders and maximum of all left borders. Yeah. In the end, I just check if right border is greater or equal than left border. Then my result is R minus L plus 1. Number of elements in the segment. Else, just output 0. So here's another solution of the same problem. Where's my Oh, where did I miss something? This maximum, this minimum. I need to multiply it again. Okay. Okay, you multiply it by n. Because of y, yes. Nice. So here are two possible solutions of the same problem. First solution works in constant time. Here, number of segments is constant, is 4 segments. This solution works in linear time. So for this problem, it's okay to use any of them because you have n is pretty small. If n is large, then you do the same with the segments. Okay. Okay, let's try. Let's submit this first. And then this one. Good. Let's move to the last two problems. So what we have? Problem G. In problem G, we have some, okay, it's mostly implementation problem, but it requires some algorithms as well. So what we have this string, it's like this. And we need to put it on some poster. Yeah? And we need to choose the width of this poster in such a way that if we put this, the whole text on this poster, the number of lines will be at most 4. So we have maximal height of this poster, and we need to choose the minimal possible width, yeah, in such a way that the height is at most of this. So what you do? No, it's the classical problem for binary search. Yeah. So let's look at this width. If you increase the width of your poster, number of lines will only decrease. Yeah? If you make the width infinite, you have only one line. If you have width very small, you have many lines. Yeah. So what you do, you just do binary search. So do binary search over the width of your poster. Then what you need to do is to calculate the number of lines for the given width. Now you can immediately see that if you know the width of your poster, you can just arrange your text using greedy algorithm. So you just arrange your text from top to bottom. Yeah, you put as many tokens in the first line as possible, then move to the second line, put as many tokens as well, and so on until you reach the end. Yeah, that's all. To make the problem a little bit more complicated, it's just to make you suffer actually. It's given in the strange notation, so it's given like this. So somewhere you have this hyphen, sometimes you have spaces, but actually for this problem it doesn't matter. So these hyphens and spaces work the same way. Yeah. So you have this so you can split your line at any space or in any hyphen, but it's just up to you. So I will just replace all these dashes with spaces and have the same problem. Yeah. Good. Let's do it. So I need to remember how to read line in this language. Oh, I don't remember. Let's try. Int k read line get line. I'll just Google it. I already Googled it. Like this. what's this second part? Ah, like this, okay. Love C++. Thank you, Google. So you read this. So you read your line. Then I need to split it. Do you have split command in this language? No. I'll just split it manually. So just don't like this. Okay, let's do it like this. So when I see something like this, I'll just make array of words. No, I need only length of these words. A. Yeah. Can I have space as the first character? Just tell me no. Before first, after the last. Okay. So should be fine. So if I have this, I will add current word here, and if not, in the end I will add. Don't like it that much, that code, but again it works. So here I just calculate length of the segments between spaces, and so I have some delimiters. Yes, this hyphens and these spaces. Yes, and just calculate now lengths of the segments between them. Well, let me express it. So. Just to check. What? I didn't read the string, right? Because I need to read the end line. Yeah. Okay, because I'm in the same line, I read this 4 in the same line. Okay. Just copy it twice. Not the best code. Okay. So 6, 3, 2, and 2. Good. Okay, let's add this last character also. So let's make +1 to any of them. +1. So I have now I have just blocks. So I have block of 7 characters, a block of 4 characters, 3 characters, and okay, this is +1. It also should be +1. Now I will just combine my lines out of these blocks. Now I write normal binary search. So yeah, calculate as so 0 is definitely not enough. Okay, what it will, so you can say is, okay, let's calculate maximum. So let's calculate maximum length of the word, or just, okay, it's just, I'll just do it inside binary search. So 0 definitely not enough length, but total length do not exceed the, okay, this is better. Let's see. So this should be definitely enough. Yeah. So now I do normally binary search. While r greater l +1, calculate middle Okay, let's do it like this. So my current line will be 0, 1. So this is my current length, and this is my total number of lines. Okay. Now I check. So I have a new block of size x. So I put it in the same. So if I can put it in the same line, I just put it in the same line. Yeah. If not, I create new line, and the size of this line will be just x. So I put this single block in this line. Okay, let's add this check. Okay, I need to check that no block is okay. Let's do this. So if x is greater than m, yes, I'll just say okay equal false. We could do before. Okay, let's keep it like this. And now if okay and number of lines is at most k, then it's enough. Yeah, it's enough means I move right pointer. Right pointer move to some always points to something good. And if it's bad, I put left pointer here. Now you need to output the minimal good value, so it will be r. So r is the minimal good value, L is the maximal bad value. Why it's 11? There is no after the last one. Okay, after the last one there is no space. So we just need to remove this space after the last one. Thank you for this example, by the way. So the problem is not very pleasant, but at least samples are pretty good. So it's also, so again, this problem basically includes two parts. So solution consists of two parts. First, you need to apply binary search. You need to think that your problem can be solved using binary search, because again, how to see a problem you can use binary search. No, you need to minimize something, and this something is kind of monotonical. So you need to find the like you just read the statement and see that they ask you to find minimal good value. So some values are good, some values are bad. And you see that if you increase this value, it will be still good. So you need to find out of all possible good values, you find the minimal one. Yeah? Then you can apply binary search. If you can check if value is good or bad, and then you think, how can I check if value is good or bad? So if I know the width, how can I check? Is it possible to fill it with k lines or not? No, and you just think, okay, I can do it using greedy algorithm. Yeah? So you apply binary search, then apply greedy algorithm here. Yeah. And also you need some implementation hacks to just to read all this thing, because authors want you to learn some programming hacks. Yeah? Like I do this also. Yeah. That's all. That's problem G. Last problem H. Problem H, again, it's not very pleasant, but it's still quite nice solvable problem. So what we have? We have some numbers called D magic. If there is a letter D, and it appears in all even positions in this line and only in these even positions. Yeah? So for example, here, if you look at all even positions, you have this, have 7, 7, and 7. Yeah? And all odd positions are not 7. So these positions are not 7, and these positions are 7. So it is 7 magic. Yeah? Because all even positions equal to 7, all odd positions not equal to 7. Kind of strange. Okay. Now they give you more examples. Let's read all other examples. So these numbers are 7 magic. This number is also 7 magic. You think, why? No, because it doesn't have any even digit. So it has digit 1 and not digit 2. And you think, okay, it means every one digit number is actually something magic. Yeah? If it's not one magic, but okay. Now you look at all these numbers and see they are not 7 magic. Okay, so 7 is not 7 magic because it has 7 in first position. First position is odd position. Here I have again 7 in odd position. Here I don't have any 7. Here I don't have 7. And here I have 7 in odd position, not in even position. Okay. Okay, you can read all other examples and kind of understand what's going on. Now let's go to the problem. The problem is to calculate number of these numbers in some segment that are multiple of multiple. Okay, what? Number of D-magic numbers in a segment that are multiple of M. Is M small? Okay, M is small. Okay. So how do we solve problems like this? No, there are multiple ways to solve problems like this. Let's split it into several parts actually. The first interesting trick you can do is actually like this. So I need to find number of integers in some segment. So I have this segment from A to B. I need to find interesting numbers in this segment. So instead of doing this, you can calculate interesting numbers in segment from, let's say, I don't have zeros. Let's say not zeros. Let's start from 1. Let's say from 1. No, 0 is kind of strange in this notation. Yes, you need to have at least 1 digit. From 1 to... is 0 magic? Okay, let's assume 0 is 0 magic for simplicity. If they have, it will not change anything. So okay, let's from 0 to B, and then we'll subtract segment from 0 to A minus 1. So now, instead of having a segment, we have some prefix. So we consider all numbers. So we need to solve problem like this. So I need to solve the same problem twice. I need to solve problem of finding good elements from 0 to some number x minus 1. So you need to count number less than x. How to look at number less than x? So if you have numbers less than x, they always look the same. So if you have, so this is your x. It is some number. Let's say some number y belongs to it. So number y is either just shorter than x. Okay. So y may be shorter than x. If number y is shorter than x, it will always be less. Yes. If we forbid leading zeros. Or number y may be the same length, but just smaller than x. If it is smaller than x, then it must have the same prefix as x. But then some digit which is less. So you have digit 1 here, for example. Here we have digit 3. Less. It means digit 3, here we have digit 1. Yeah? So we have all the same digits, but here we have different digit, and this digit is smaller. So that's how you construct the numbers. Yeah? So you consider all numbers of which are shorter and all numbers of the same length, but when you go from left to right, you see the number, you see the same prefix, but then digit which is smaller here than here. Okay. Just thinking about what is the supposed time complexity. Am I fine here? This should be fine. So all the integers of this shorter than x, we will just calculate easily. Yeah. So you have integer smaller than x, you know all the positions. So if you can take any integer, so you take this number x, yeah, you know its length, you know that these positions are d, yeah, and these positions are not d, yeah. So you just count number of ways to put these middle positions not d. It will be like 10 minus d multiplied 10 minus 9. So you have 9 possible positions. So you have 9 positions for every. So number of integer will be like 9 power number of this. Oh, what again? So start from yeah. So number of if this number is shorter than x, yeah, then you just calculate number of ways to choose these positions. It will be 9 power number of this position. If y has the same length, that's more interesting part. So if y has the same length, they have the same length, so it doesn't matter. It's boring problem. Okay. So in this problem, a and b have the same length, so you don't need actually to use this part. But just okay, if you're interested, that's how you do it. Yeah. So basically, all integers we're looking for have the same length because a and b have the same length. Boring. Okay, but okay. It would not change anything in this solution actually, but they decide to make your life easier. Let's thank the authors for this bless. Yeah. Now, what we do here, if we have the same length, we need to construct the number like this. We go from left to right, put the same digits as in x, then put one digit. So it's okay. How the number? You give a number x. Okay. Let's erase everything. So give a number x. How you construct number y? You go from left to right. You put the same characters as in x. Yeah? So you just copy these characters to here. Then at some point, you put the character which is less than in x. So here you put character a, here you put some character b which is less than, digit, not character, yeah? Some digit b which is less than in a. Yeah? And then you put anything in the rest. Good? So you put some here, and then anything in the rest. That's all. That's how you construct number y. Now, when you know how to construct number y, you need to calculate number of ways to construct this number in such a way that it is divisible by m. So you also need to be multiple of m. Now, how you construct numbers divisible by m? No, you also need to think about the current remainder modulo m. So I will do it like this. So again, the solution will look like this. I will build my number y from left to right. Yeah. So I'll build my number from left to right, y. Yeah. So what I need to remember about this prefix I already built. For this prefix that I already built, I need to remember if I already have this, if I already put at least one digit less than a. So am I in here or am I in here? Yeah. So I need to remember this part. And I need to remember the current remainder modulo m. Okay? Now for every length of the prefix and every remainder modulo m, so this number is y. Modulo m. For every remainder modulo m, I will remember the dynamic programming like number of ways to do it. You can draw it, must be. Just don't do it, please. Good. So now we just build dynamic programming. Again, the state of your dynamic programming depends on the number of characters you put, number of digits you put, and the current remainder modulo m. Let me show you how to do it. So we have M and D. Okay. I'll just read them as strings. Okay. Now I will. Okay. I'll do long res equal to calc of B. Okay. Calc of B. Okay, I need -1. Oh, I don't like this. Okay, the problem is okay. So like I show you. So I want to calculate segment from A to B. Yes. And to do this, I need to calculate segment from 0 to B and segment from 0 to A minus 1. And to do this, I can calculate B plus 1 here. I don't like this. Let's just subtract 1 instead. So let's calculate it in A. So, I don't like this problem anymore. Okay. Okay, let's calculate inclusive. So let's say y is less or equal than x. So I will allow this prefix to be to the end because it's easier to subtract ones. When you subtract one, you cannot get overflow. Okay. Let's subtract one from B. No, from A. So I will subtract one from A. So I will say if AI not equals 0. So how do you subtract 1? You find the first digit which is not 0. So if it is not 0, then I will decrease it. Yeah? And if not, I will just put 9 in this position. Okay, let's say, okay, so result will be calc of B minus calc of A. Let's say res equal to res modulo. What modulo do we calculate? Okay, what if res less 0, res 1 more, and we calculate if n is const long mod equal like this. Okay? Yep. Now I just need to write this calc function. Good. Okay, I need M and D also here. Okay. Good. Now here again. I'll just use dynamic programming again. How you calculate dynamic programming? Let's do it like this. I will calculate number of ways. Again, so again, when I look at the prefix, I need to remember in which part I'm here and here, and the current remainder modulo m. So I will calculate in two parts. D1 is when I in first part here. and D2 will be when I'm already in here, when I already have at least one digit less than an X. Let's call it X, so it's like in this picture, yes. So D1 will have, well, both they have the size n. So in the beginning, I'm in part 1, so I will say D1 with remainder 0 is 1. Okay? So it's when we have empty prefix here. Empty prefix is in the first part, and the current remainder is 0. Yeah? I'll just add all the characters one by one. Do I need this n? I don't need this n. Okay, I still need, okay. Because I need to remember what is the position, is this odd or even, yeah? Now, let's try to put all possible characters to this position. So, I'll do it like this. Now, let's say which characters we cannot put. So, first of all, we cannot, so if I equals 0, we cannot put digit 0. So, and C equals 0, continue. Nice. Then, if position is odd, I cannot put digit D. Wait, okay, let's. I don't like this. And okay, and C equals D. Then, if position is even and C equal not equal D, or is it like this? So position 0 must, okay, 0 must be not equal. Okay, so if it is equal and if it's not equal, okay. Okay. Now, let's see in which part. If we are in part 1, so it's like in this part. So if we see digit which is less, so if we see digit which is less than corresponding digit of the X, then we move from part 1 to part 2. Yeah, so I will just, okay, I'll just implement it like this. So I move from one layer of dynamic program to another layer. So it will be a new layer of my dynamic programming. Yeah? Okay, you need to iterate over. Okay. Okay. So J is my current remainder modulo M. So okay, let's calculate. My new remainder modulo M will be JJ multiplied by 10 plus C. Yes, modulo M. So this is my old remainder. If I add another digit to the right, my new remainder will be multiplied by 10 and plus C. Yeah? Okay, so if my new digit is less, then I will just move from part 1 to part 2. So I'll say dd2 of dj, yeah, plus equal d1g. Calculate modulo. Good. If you have the same digit, then you move, then you stay in part 1. Yeah, so you stay with part 1 but with new remainder. Okay, okay. Here we processed all the transitions from the first part. So if we stayed here, we look at the next digit, see what will be the next state of the dynamic programming. Now we just need to process the state where we in the second part. So when we're here, when we're here, we actually can put any digit and still be in part 2. So we'll just do it like this. I believe that's it. Yeah. So the result will be okay. So you need to replace it. Move to the next layer of the name programming. Yeah? So result will be just total number of strings with reminder 0. Okay, it's calculated modulo. We calculate modulo in the end, but just to look nice. I believe it's like this. Did I miss something? Identity, okay. Yeah, looks fine. Okay, that was not easy problem at all. So you need to think a lot, then implement some strange dynamic programming. Not easy problem. Okay, I agree. So everybody who solved this last problem actually very good result. Oh. Do I have some overflows? Interesting. Oh no, it just makes you calculate something. I don't want to debug this. So last week we was happy because we didn't have to debug anything. This time we actually need to debug. Don't like it. Let's read it really quick. So we have this size, we have 22, tak. Initially we have fig equals 1. Makes sense. Okay, but that's look at this current method. Okay, choose digit, calculate the next remainder. So we don't allow to put 0 in the first position. It doesn't matter in this test case. It doesn't matter in this case. We don't have first position. What is it? 0? 0. 0 is digit. Okay, 0 is okay digit. Is something not the digit 0? Shouldn't be. No, should be fine. Why? 0 is normal digit. I just don't put it in the first position. I don't have to. So I calculate less. I calculate more than, okay. Okay, so these positions should, okay, should be D. This position shouldn't be D. Okay. Makes sense. Looks okay. Okay, break. Okay. I forgot to break. Okay. I don't know how to subtract 1 from the number. Okay. It's actually fun that sometimes you have problems in the simplest part of your program. So you would expect to have bugs in this part because it's some strange, complicated program, yes. But actually, you have bugs in some non-important part. Like here, I need to subtract 1 from a number. Yeah. So you go from right to left. If digit is not 0, you subtract 1 and then break because you stop here. Yeah. And if it is 0, you just replace it as 0. Okay. So I made back in this part, not in hard part, in simple part. Yeah. So it's something you should also be careful about it. If you have some wrong answer, it's not always in the hard part of your program. Sometimes it's just in easy part of your program because you just make simple typo or something like this. So be careful about it. Okay, so that's it for today. See you next week. Next week we will not have a contest here. We will discuss contest from the youth challenge. So we will have youth challenge on Sunday. And I will add, after the Sunday, if you don't participate in the youth challenge, I will add the same contest to the Code Forces group for the coding club. So you'll have chance to solve the youth challenge by yourself. It will be much harder than the contest we usually have, but still the first few problems will be approachable for you, I believe. So see you next week. We'll discuss youth challenge. Okay.